Hello and welcome back. We'll finish up this lesson in this video looking at another example of taking the derivative. So again, the derivative is just the instantaneous rate of change, meaning it's the slope of a function at one point. At that instantaneous point in time, it is the slope of the function. And again, the slope, the difference between 2 points, the slope of the function we've given as the difference quotient, as in the slope between a point and a point really close to it, only a hair away. And as we let that hair get thinner and thinner and thinner, we're finding the slope closer and closer and closer to that point. And if we take the limit exactly, that's going to be the slope right at that point. So we found the slope of the function f of x is equal to x cubed. Let's highlight this. So what we did is we found the difference quotient, and then we took the limit. And again, here, if we're taking the limit as as h approaches 0, x isn't changing, x isn't moving. We should just treat x as a constant. So as h approaches 0, h squared is going to go to 0. As h approaches 0, something times h is also going to go to 0. And our only constant term here is going to be left over. So if you look at the graph of x cubed, the slope is going to change according to 3x squared. And let's do one final example of a derivative. Let's take the derivative of the square root of x. So first things first, let's find the difference quotient here. So we've called this function g, so we're finding the derivative, so I need to find the limit as h approaches 0 of the difference quotient. We'll start there. So what we want is going to be g of x plus h minus g of x all over h. So far so good. And now we can plug in x plus h into our function. So this is going to be the square root of x plus h minus the square root of x all over h. And maybe at a glance, there isn't necessarily a very good way to simplify this right now. But if we let h go to 0, I'm going to be dividing by 0 here. So I really don't want h to go to 0. Or I should say I really don't want this h on the bottom of the fraction. So we've got to find a way to cancel it out. And there's a nice trick. What we're going to do is we're going to multiply the top and bottom by the conjugate of the numerator. So let me write this down. This is just a trick that helps deal with square roots. So here, I don't like this h on the bottom. So what I'm going to do is I'm going to multiply by the conjugate, meaning I'm going to take the top and I'm going to change it so that it's a plus sign there. Cool. So now we have this big mess to deal with. The nice thing is at the top, we know that if I take a plus b times a minus b, I should get a squared minus b squared. So this is the same thing. I have a minus b times a plus b. So this is going to be a squared minus b squared. We could also FOIL this out. So this would be the first two terms multiplied together, the last two terms multiplied together, and then the outer and inner terms are going to cancel because one will be negative and one will be positive. On the bottom of the fraction, I just have h times the square root of x plus h plus the square root of x. So far, nothing really looks simpler, and in fact maybe this looks more complicated, but we're going to watch as things cancel. what is the square root of x plus h squared? Well, that's just going to be x plus h. Likewise, what is the square root of x squared? It's going to be x. And before our very eyes, everything is going to start canceling. Positive x and negative x. H and h. So our difference quotient is going to be 1 divided by the square root of x plus h plus the square root of x. The x is on top cancel, and then the h on the top and bottom will cancel as well. So this is what we're left with. This is not too bad. It's a little bit complicated, especially considering we started with something that's usually fairly simple, just the square root of x. But our difference quotient ends up here. Let's take a limit. So I want the limit as h approaches 0 of 1 divided by the square root of x plus h plus the square root of x. And here, I want to go through this fairly carefully. We have a limit of two things being divided. So we'll just take the limit of the top over the limit of the bottom. And in fact, if I'm going to take the limit of the bottom, I might as well take the limit of the thing on the left plus the limit of the thing on the right. And here, a lot of things are going to simplify. The limit of a constant function is itself. It's just that constant. Over here, the square root of x, x doesn't change with h. X is just a fixed number. So the limit of this guy is just the square root of x. Again, x, according to h, isn't changing. X is just going to be some number. So the limit of a constant function is just going to be that constant. And here, I'm taking the limit as h approaches 0 of this guy. So this is going to be the square root of the limit of x plus h as h approaches 0. And finally, we've got a 1 on top. We've got the square root of x over there. The square root of this limit. Well, what happens as we take the limit as h approaches 0? Well, h goes to 0, and it just goes away. X is just a constant function according to h. So this limit is just the square root of x. As in, the limit is x, and we're taking the square root of all that. And this simplifies to 1 over 2 square root of x. Derivatives can be quite tricky at first. We will see tricks that will make this a lot easier. We'll see that there are ways to express functions so that we can see what the derivative is without doing essentially any work. But until that point, we do want to be using this limit. We find the difference quotient, and we take the limit as h approaches 0. And the one thing that I want to stress is that if we're taking the limit as h approaches 0, x isn't changing, and you should treat it as a constant in the limit. If you have questions, if the homework is being tricky, contact me, reach out to me, come to class, ask questions. This is why I'm here. I'd love to hear from you.